My name is Jentsje van der Meer. This presentation is about wave overtopping tests we have performed with a wave overtopping simulator on a test dike in tropical conditions. There are many co-authors from the client, advisors, the contractor, etc. I will first introduce the project and why we do the overtopping tests. To carry out the tests, we have made a test dike or mock-up dike. We also designed and constructed a dedicated wave overtopping simulator. I will tell about the tests we did and of course about the results. And finally, I will end up with the conclusions. The project is located in Asia in a tropical area. It is a coastal project where a dike has to protect the area from flooding. And the objectives of the project are, firstly, to discover what grass type and topsoil is the best as a grass cover on the landward dike slope. From the test results, the best combination will be used in the project for the real dike. Secondly, we will also test for very large overtopping, really far beyond design conditions, just to see how the grass cover will fail. This is therefore a more scientific aspect, as we don't think those conditions will ever happen in reality. The method to achieve the objectives is quite simple. Construct a test dike and a simulator and perform the tests. The realization of this all takes, of course, a significant effort. Here you see the project site where we have constructed the test dike. The dike will have a landward slope of 1:3 and consists of a sand core covered with 2 layers of clay, a subsoil of 0.4 meters and a topsoil of 0.3 meters, where the grass will be seeded and grow. This landward slope was constructed for the test sections and resulting in a 100 meters long test dike. This is a picture where the clay layers have been constructed and the next step is to hydroseed the grass. 3 weeks later, the grass started to grow. And after half a year, we had already nice grass cover, but not yet fully matured. After 1 year, we assumed that a grass cover would represent its final stage and we started testing. In order to be able to test for wave overtopping, we have designed and constructed a dedicated wave overtopping simulator. Dedicated by improving our existing Dutch simulator and by designing it for the actual wave conditions at site. The real extreme wave heights were expected to be between 1.2 and 1.5 meters. The overtopping discharge to be tested is then related to an assumed water level that gives this discharge. Individual overtopping wave volumes can then be calculated and these are simulated by the machine. The simulator was constructed in the Netherlands and was 4 meters wide with a volume of 4.4 cubic meters per meter width. With this width, the maximum volume in the simulator became 17.6 cubic meters. Then the simulator was placed in parts in a container. First the upper and middle box, and then the lower frame. And there was still space for other items to take with us to the project site. The proposed tests are related to questions the client and advisors had. They would like to test 2 specific grass species, Bermuda and Manila grass, and a combination of both. And they would like to investigate 2 different topsoils called HDB and couch. And this gives in total 6 tests. 2 tests were added on a specific cross-section with transitions in it. What we noticed is that the mixed grasses were fully taken over by Bermuda. It seems that Bermuda develops faster after seeding without a chance for the Manila to start to grow. In order to be able to say something about the strength of the grass and to relate it to Dutch or northern conditions, it was necessary to measure the front velocity of the overtopping wave volumes. For the time being, this was done by taking a video with a dome camera. Each block on the video is 1 square meter, and by counting the number of frames in the video over 2 meters, it is possible to determine the front velocity over that distance and also over the full slope. Here we see quite a lot of results on front velocity on the vertical axis versus the released overtopping wave volume. The velocity increases with increasing volume. The yellow line gives the velocities at the crest of the original Dutch simulator, and we wanted to have a little larger velocities for the new dedicated one. The yellow circles show indeed larger velocities, where it must be noted that the two points at the right are not very accurate and probably unreliable. The blue circles give the front velocity 5 meters from the crest, where the water starts to accelerate. The maximum velocity, the green circles, was reached around 9 to 15 meters from the crest, and velocities up to 9 meters were measured here. As of today, we have performed 2 tests, up to 50 liters per second per meter. Both Bermuda and Manila grass were tested with a couch topsoil. We found 2 significant results. Both grass species were strong and showed no damage. But the topsoil showed overall and localized erosion of soil over the whole area. This was most pronounced, of course, at the 50 liters per second per meter overtopping, which is at a rate quite far beyond the design requirements. This overall erosion was unexpected, and we had never seen that before in any testing we did. Besides overtopping tests, we have also performed grass pool tests, half a year after seeding of the grass, and again, just before the wave overtopping tests. These tests measure the strength of the grass roots, and that is also a measure for the strength of the grass cover. The results showed that there were slightly better results for Bermuda than for Manila. And from the results, it is concluded that the Bermuda grass was preferred and that a couch topsoil was not recommended as a grass cover for the dike. How does the tropical grass relate to the grass we have in colder countries? We have developed the so-called cumulative overload method, and you see here the basic version of it. We compare the front velocity of each overtopping wave, Ui, with a strength parameter or critical velocity, Uc, for the grass. For each front velocity that is larger than this strength parameter, a damage value is calculated, and the total damage values together is what we call the cumulative damage D. From our long-lasting test program in the Netherlands, we know when a certain damage may occur, like initial damage, several open spots, and the most important one, failure of the grass cover. We found strength parameters UC for 3 situations. Well-maintained grass on a clay layer with UC is 8 meters per second. Maintained grass, but with some open spots on a clay layer with UC is 6 meters per second. And well-maintained grass directly on sand without a clay layer with UC is 3.5 meters per second. The tests with Bermuda and Manila grass on couch topsoil showed for the system as a whole a critical velocity of UC is 6 meters per second, which is a good value for a grass cover. This is similar to findings from the Netherlands, which reflects maintained grass, but with open spots on a clay layer. The grass itself showed no damage and has a critical velocity of at least 7 meters per second. Except for the overall erosion of the topsoil, the tropical grass species seem to be more or less equal to the grass species in the northern countries. These are the results we have so far. Finally, the conclusions of the investigations are summarized here. We made a mock-up dike, as well as a dedicated wave overtopping simulator. And based on the tests carried out so far, the results showed overall a localized erosion of the topsoil for the huge soil mix. This topsoil is not recommended, therefore, and we found no difference between the Bermuda and Manila grass. Due to better results for the Bermuda grass with the grass pool tests, this grass is preferred for the real dike. And finally, we hope to complete the remaining tests by end of November. Thank you for your attention.